Imagine this. In real life, problems don't come to us as numbers or equations. They come as situations, as stories, as words. When you budget your money, plan your time, or even run a small business, you don't start with X and Y. You start with understanding what is happening. And this is where algebra begins. Algebra is not just about solving equations. It is about translating words into mathematical language. When you hear phrases like twice a number, 5 more than, or the product of, these are not just words, they are clues. Clues that can be transformed into expressions like 2x, x plus 5, or xy. Once you learn how to translate these, you unlock the problem. Without this skill, word problems feel confusing and difficult. But with it, everything becomes clearer, more organized, and easier to solve. This is why this topic is important. It strengthens your foundation in algebra, develops your critical thinking, and prepares you for real-life situations. From managing money to solving complex problems in the future. Think of it this way. Learning this skill is like learning a new language, the language of mathematics. And once you understand this language, you don't just solve problems. You begin to think like a mathematician. So the next time you see a word problem, don't be intimidated. See it as a puzzle, waiting for you to decode. Today, we're going to break down one of the most important skills in algebra, translating words into mathematical expressions. Whether you're a student trying to understand word problems or a teacher looking for ways to explain this clearly, this lesson is for you. Let's go step by step, from basic to advanced. Basic expressions. Let's start simple. When we say a number, we represent it as x. Now try these with me. Twice a number, that becomes 2x. Thrice a number, 3x. The square of a number, x is squared. The cube of a number, x cubed. Half of a number, x divided by 2. Simple, right? We're just giving symbols to unknown values. Addition and subtraction. Now let's move to combining values. Listen carefully. A number plus 5, x plus 5. A number minus 3, x minus 3. 7 more than a number, still x plus 7. 10 less than a number, x minus 10. The difference between 15 and a number, 15 minus x. Quick check. Notice how less than and minus can change the order? That's a common mistake, so be careful. Multiplication. Now let's build expressions with multiplication. Twice a number plus 4. 2. X plus 4, 3 times a number, minus 2. 3x minus 2. The product of 5 and a number, 5x, 4 times the sum of a number, and 3, 4. Open parenthesis, x plus 3, close parenthesis. Twice the difference of a number, and 6, 2, open parenthesis, x minus 6, close parenthesis. Notice something? When you hear sum or difference, think of grouping first. Division or rational expressions. Now let's divide. A number divided by 4. X over 4. The quotient of a number and 5, x over 5. The ratio of a number to 3 times, x over 3. Twice a number divided by 6, 2, x over 6. The sum of a number and 8 divided by 2, x plus 8 over 2. Important reminder, when dividing a sum, we divide the entire expression, not just one part. Powers and expressions. Let's raise the level a bit. Twice the square of a number. 2, x squared, the square of a number, plus 6. X squared plus 6. The cube of a number, minus 2. X cubed minus 2. 3 times the square of a number, minus 5. 3x squared minus 5. The sum of a number and its square, x plus x squared. Here, the key is recognizing powers like square and cube. Multi-step expressions. Now we combine operations. Twice the sum of a number and 4. 2 open parenthesis, x plus 4. Close parenthesis. 3 times the difference of a number and 2. 3 open parenthesis, x minus 2. Close parenthesis. 5 more than twice a number. 2. X plus 5. 7 less than 3 times a number. 3. X minus 7. The sum of twice a number and its square. 2. X plus x squared. Now we're thinking in steps. What comes first? What comes next? advanced/algebraic thinking. Now let's challenge ourselves. The product of a number and the sum of the number and 3. X plus 3. The quotient of the sum of a number and 6 and 2. Open parenthesis, x plus 6. Close parenthesis over 2. The square of the sum of a number and 5. Open parenthesis, x plus 5. Close parenthesis, squared, the product of two consecutive numbers. X, open parenthesis, x plus 1. Close parenthesis, the sum of three consecutive numbers. X plus 1 plus x plus 2. Now this is where algebra becomes powerful. We're not just translating, we're modeling real patterns. So whether you're a student or a teacher, remember this. Mathematics is a language, and these phrases are its vocabulary. Once you understand how to translate them, word problems become less intimidating and more like puzzles you can solve step by step. If you found this helpful, feel free to share this with your students or colleagues. And if you want more lessons like this, just let me know in the comments. See you in the next one.